Hello everyone. As you saw in my previous videos, I tried to fly drones by hand using a remote control. This was very unstable and it required a lot of practice. I crashed many times. I want to eliminate human error by using automated control. As such, I want to make a drone using a Raspberry Pi with MAVLink communication so I can control my drone with Python code. I believe that the drone will be easier to control if I'm not controlling the drone with a remote control, but rather with a keyboard and mouse. I had previous experience with the Raspberry Pi Pico, however, I needed higher performing ones because flying a drone requires more computing power than just powering LEDs and calculators. So I bought the Raspberry Pi Zero. I accomplished the following. Established a headless SSH connection to the Pi to install MAVProxy on it. Soldered the Pi onto the flight controller using the UART outputs in the Raspberry Pi. Set up the flight controller with Mission Planner to enable the UART ports. Set the baud rate to 115200 and set the protocol to MAVLink 2. Established a connection between my flight controller and Raspberry Pi. To do this, I opened Windows PowerShell, SSH'd into the Raspberry Pi, then went to the path where I installed MAVProxy, which was .local/bin, then typed in this line of code. To ensure communication between the flight controller and the Raspberry Pi, I did a motor test, so I used this line. This is confirmation that communication between the flight controller and the Raspberry Pi was established. I then had to get my drone ready to fly and arm. I want to be able to run a Python code from my Raspberry Pi so it communicates with the flight controller and makes it fly or land or other actions. This first step was going through the mandatory hardware list. If I make any changes, I'll be sure to describe what I did. However, the only notable thing I did was disable the compass because I had a GPS. I also disabled the RC because I don't have one for this drone. As you can see in this picture, my drone is ready to arm. I then wanted to try to run a code on the Raspberry Pi. So to be consistent, I wrote a code to do the motor test. Here is the code and here's the clip of the code in action. Stay tuned because I'm experimenting how to write more enhanced codes. My goal is to make the drone take off, fly forward a little bit, like 1 meter, and then land, all without any human input, therefore no human error. Thank you for watching.